Now, question 5. In an archery competition, the team consisting of John, David and Mike will win first prize if at least 2 of them hit the bullseye with their last arrows. From past experience, they know that the probability that John, David and Mike will hit the bullseye on their last arrow is 1/5, 1/6 and 1/4 or 1/4 respectively. Complete the table below to show all the ways in which they could win first prize. So in order to win first prize, we're told in the question there that at least 2 of them have to hit the bullseye. Now in this you can see the key there, a tick is denoted as a hit, in other words hit the bullseye, and obviously an X is a miss. So at least 2 of them have to get it. So you see here in way 1, the first 2 of them there, John and David, hit the bullseye. So I'm going to say then in way 2 that David is now going to miss, so it's John and Mike that hit the bullseye. In way 3 then, it's the last 2 fellas, it's David and Mike that hit the bullseye. Now in way 4, what are our options that are remaining? Well, we can't have one person hitting the bullseye because then 2 would miss and then they wouldn't win it. We can't have them all missing because then they won't win. So the only other alternative is that they all hit the bullseye. Remember the question in what's highlighted there, at least 2 of them. So that could mean that all 3 of them hit the bullseye. So that's the table filled out there. Now part 2 of the question, hence or otherwise find the probability that they will win the competition. So what I've said there, the probability that they win, it's either the probability of way 1 or the probability of way 2 or 3 or 4. Now remember, every time we use the word and in probability, we use multiplication, and every time we use this word here or, we are using addition. So we need to remember that. Okay, so the probability, working it out here for way 1. So way 1 is the first way that they win the prize, as it were. So that means that John hits and David hits and Mike misses. Now the numbers are given to us up there. I'll just put there's a J for John, this is a D for David, and the last one there is M for Mike. Okay, so John and David are successful, so that means we're saying it's 1/5 and David, so that's 1/6, and Mike misses. So the success of Mike hitting is 1 in 4, so of him missing is 3 in 4. Okay, so multiply them all out there and we get 3 over 120. That's the chances of that happening. Okay, we move to way 2. So way 2 basically means that John hits, David misses, and Mike hits, using the same probabilities again. So John hits, that's 1/5. David misses, so the success rate for David is 1 in 6, so of him missing is 5 in 6, and then of Mike hitting is 1 in 4. So you can just scroll down there, 1/5 times 5/6 times 1/4. Okay, now the third way, it means John misses. His probability was 1 in 5, I think. Yeah, 1 in 5. So of him missing, so that's going to be 4 in 5. And then David and Mike both scoring, that's 1/6 times 1/4. So you can see it's going to be 4/5 times 1/6 times 1/4, and we have multiplied that out there as well. Okay, and the very last one then, way 4, basically all of them hit. So that is 1/5 times 1/6 times 1/4. And the chances of that happening are 1 in 120, so not very likely. Alright, you can remember the way we said it was going to be the probability of way 1 or 2 or 3 or 4. So we're adding them all up, which basically means we are adding these numbers up there. Okay, so 3 1/20ths plus 5 1/20ths plus 4 1/20ths plus 1 1/20ths. Okay, I'll just make that a little bit larger there. Altogether that comes to 13 over 120. So the probability of that happening is 13 over 120. which is equal to 0.108. I might just add that in there. 108. Okay, part B of this question. Two events, A and B, are represented in the diagram there, as we can see. Now remember, the probability of A there is those two numbers together, and the same is true for B. It's those two numbers together. So we'll just remember that before we even start this question. Okay, so two events A and B are represented in the diagram. The probability of A and B is 0.1, we can see that. The probability of B less A is 0.3, and the probability of A less B is equal to X. Write P of A in terms of X, and hence or otherwise find the value of X. Right, well, P of A, I haven't actually just done, so the probability of A is X plus 0.1. Okay, now hence or otherwise find the value of X for which the events A and B are independent. Okay, if they are independent, so we're looking at the probability of A and B is equal to the probability of A times the probability of B. And once you can recognize that as independent events, the rest of the question should be relatively straightforward. Okay, A and B, that's the middle section there, that's 0.1, is equal to probability of A. You can see that it's those two numbers added up. And I've mentioned that up the top there as well. And that's going to be multiplied by the probability of B, which is those two numbers there added up. Okay, now I've just used the, as you can see there, that symbol there as multiply, because I didn't want to mix up the multiply and the X sign there. Okay, so on the right hand side, so we get 0.4. So it's X plus 0.1, and all that is to be multiplied by 0.4. And that's equal to 0.1. So we're going to work this out by dividing across by 0.4. So 0.1 divided by 0.4 is equal to X plus 0.1. And you can see the rest of the calculations there going down the way. So we get X is equal to 0.15. That's the left hand side of the diagram there, X. Okay. So I've just added in then the idea of what probability of A actually is. Remember up above there we said that it was X plus 0.1. Well, we now know what X is, so there used to be X. It's now, I've subbed in 0.15 plus 0.1 is equal to 0.25. Okay, I just listed X there as well. I think that was part of the question anyways when it came in. Okay, that's the end of that question there.